Helicopter 9-3 Basic Flight Maneuvers. Our exploration into helicopter maneuvers brings us to the captivating realm of hovering, a skillful display of control and precision, maintaining the helicopter nearly motionless over a reference point at a constant altitude and heading. In this aerial ballet, the pilot's technique is of paramount importance. To sustain a hover over a point, keen observation is essential. Utilizing side view and peripheral vision, the pilot identifies subtle changes in the helicopter's attitude and altitude. Small, coordinated corrections are then made before any noticeable movement occurs, ensuring a seamless hover. It's crucial to maintain a primary focus at a distance from the aircraft, preventing overcontrolling. The collective and throttle govern altitude and RPM, while the cyclic and pedals control the helicopter's position and heading. As with any maneuver, common errors lurk, waiting to challenge the pilot's finesse. Tenseness and delayed reactions to helicopter movements must be avoided. It's imperative to factor in the inherent lag in cyclic and collective pitch, preventing overcontrolling, a common pitfall for students getting ahead of the helicopter. Confusion between attitude and altitude changes should be evaded, as improper use of controls may result. Hovering at inappropriate heights, either too high or too low, poses significant risks. Pilots must consult the height velocity chart to determine safe skid heights and prevent hazardous conditions. Now, let's delve into the graceful hovering turn, a maneuver requiring impeccable coordination. Initiate the turn by applying anti-torque pedal pressure toward the desired direction. The cyclic is employed, usually into the wind, to keep the helicopter over the reference point. As the turn progresses, additional pedal pressure compensates for crosswind forces. A judicious blend of cyclic, collective, and throttle ensures a constant altitude, rate of turn, and RPM. Navigating the 180-degree portion demands anticipation of opposite pedal pressure due to the tail moving from an upwind to a downwind position. The tail's tendency to weathervane necessitates continuous pedal adjustments to maintain the same rate of turn. As the turn concludes, opposite pedal pressure stops the motion, and gradual forward cyclic pressure prevents drift. Yet, even in this aerial waltz, common errors persist. Maintaining a slow, constant rate of turn is critical, as is the steady positioning over the reference point. RPM must remain within the normal range, and altitude should be unwavering. Proper use of anti-torque pedals is imperative to the success of the maneuver. Let's continue our exploration into the artistry of helicopter flight, focusing now on the graceful maneuvers of hovering, specifically, forward and sideward flight. Forward hovering flight, a dance across the sky, is initiated to transport the helicopter smoothly to a specific location. Imagine this aerial waltz beginning from a stationary hover, maintaining a constant ground speed, altitude, and heading throughout the performance. The technique involves selecting two references directly in front, aligning with the helicopter, and maintaining this alignment throughout the maneuver. As the maneuver commences, the pilot applies gentle forward pressure on the cyclic, allowing the helicopter to gracefully move forward. To achieve a constant, controlled ground speed, no faster than a brisk walk, the cyclic is carefully returned towards the neutral position. The dance continues, with the pilot maintaining a harmonious balance, constant ground speed with the cyclic, heading with the anti-torque pedals, altitude with the collective, and a steady rhythm with the throttle. To conclude the forward movement, the pilot applies a tender rearward pressure on the cyclic, bringing the helicopter to a gentle stop. The cyclic is then returned to neutral, preventing any rearward drift. Alternatively, forward motion can be stopped by gently applying rearward pressure to level the helicopter, allowing it to drift to a graceful stop. Now, onto sideward hovering flight, a delicate movement when forward flight is impractical. Here, a constant ground speed, altitude, and heading are maintained with precision. Before embarking on this aerial ballet, the pilot ensures the area is clear, paying particular attention to tail rotor clearance. Two inline reference points guide the dance in the direction of sideward hovering flight. As the maneuver begins, the pilot applies cyclic toward the desired side, gently returning it to neutral to maintain a controlled ground speed, no faster than a brisk walk. In this sideward waltz, the pilot orchestrates a symphony, constant ground speed and track with the cyclic, perpendicular heading to the ground track with the anti-torque pedals, constant altitude with the collective, and the perfect cadence with the throttle. To bring this aerial ballet to a pause, the pilot applies cyclic pressure in the opposite direction of movement, holding it until the helicopter gracefully comes to a stop. As the motion ceases, the cyclic returns to neutral, preventing movement in the opposite direction. Alternatively, sufficient opposite cyclic pressure can be applied to level the helicopter, allowing it to drift to a stop. Yet, even in these dances of the sky, common errors loom. Exaggerated cyclic movements, improper anti-torque pedal control, failure to maintain desired hovering height, negligence of proper RPM, and overlooking the need for a clear area prior to the maneuver can disrupt the fluidity of the performance. Greetings, aviation enthusiasts. In our ongoing exploration of helicopter maneuvers, let's delve into the intricacies of hovering in rearward flight, an essential skill when forward or sideward movement is not feasible. Before we proceed, it's crucial to acknowledge the unique challenges posed by rearward flight. The limited visibility behind the helicopter emphasizes the importance of clearing the area behind the aircraft before initiating the maneuver. Ground personnel can play a vital role in ensuring the safety of this operation. As the helicopter gracefully maneuvers backward, envision 2 reference points selected in front and in line with the aircraft, serving as visual guides throughout the intricate performance. The helicopter begins its gentle rearward movement from a standard hovering height, with the pilot applying subtle rearward pressure on the cyclic. To maintain precision in this aerial navigation, the cyclic is deftly positioned to ensure a controlled and deliberate ground speed, no faster than a brisk walk. Throughout the maneuver, the pilot orchestrates a seamless blend, constant ground speed and ground track with the cyclic, a steadfast heading with the anti-torque pedals, unwavering altitude with the collective, and a consistent rhythm with the throttle. To gracefully conclude this backward movement, the pilot delicately applies forward cyclic pressure, holding it until the helicopter comes to a gentle stop. As the motion halts, the cyclic returns to its neutral position. Alternatively, a touch of opposite cyclic can be employed, gently leveling the helicopter and allowing it to drift to a stop. It's crucial to maintain tail rotor clearance during this maneuver, and maintaining a slightly higher than normal hover altitude is often recommended. Yet, as in any complex maneuver, common errors may disrupt the fluidity of the operation. Exaggerated cyclic movements, improper anti-torque pedal control, failure to maintain the desired hovering height, neglecting proper RPM, and overlooking the need for a clear area prior to the maneuver are pitfalls to avoid in this delicate process. In conclusion, mastering the art of rearward hovering flight allows the pilot to command a seamless operation in the sky. Thank you for joining me on this journey through the intricacies of helicopter maneuvers, and until our next discussion, may your flights be smooth and skies be clear. Safe travels.